Hello, I hope you are able to hear me. So today we will look into two topics. First one is about compiler generated function. I don't know whether I'm sharing my screen or not. Okay, let me share my screen. So today we will look into two topics. First one will be like compiler generated function, and second topic would be about resource management. This is where we would look into smart pointers, like unique pointer, shared pointers. So that's something we will study today. And So basically for that, what you need to do is you need to go inside this folder, and over there you would find like all those examples that I compiled. And you could go through one of each of them and you would understand what exactly uh, like these topics are and how exactly they're helping us to take whatever we learn inside basic C++ forward and use this language more robustly. So that's something we would look into. So inside this folder, I have also added like one text file over here, chapter2.md. So over here, I have also added explanation for all the topic that we would be discussing in this lecture. And for each of the topic, I also added like examples so that it would be easier for us to absorb those concepts easily. So in this section, we will learn about what are the compiler generated functions. So that would be like major chunk of this video. And inside compiler generated function, we would look into what are the default constructor, what are the so first of all, we would understand why do we need a compiler generated function. Then we would go further. We would learn about default constructor. We would learn about copy constructor. We would learn about copy assignment operator, move constructor, and move assignment operator. Then we would also learn about value categories and what are the R value references. We would look into return value optimization and how exactly it's benefiting us. So that's something we would look into. This is for like this video, and in next video we would look into like resource management. So let's learn more about what are the compiler generated functions. So we all know like when inside C++ programming language, since it support object-oriented programming framework, it has like four pillars. First one is a encapsulation. So whatever object or whatever class that we want to write, we could include all the data members and all the method inside that one class. Uh, Inside header file, we could declare them, and inside .cpp file, we can define them. But we would be having all of them inside that class only. So this is how we would like encapsulate them. And then for abstraction, we just need to mention class name, and then later on we could also implement inheritance and polymorphism out of it. But the thing that we need to look into is like whenever we are looking into like C++ like class explanation, like if I go back and if I show you like the class definition that I have over here, so dog HPP. So over here you would see like I have created class dog, but I have added like data members, name and license number, and I have added some methods. But I haven't added like any constructor over here that would give like some default values to this data member, which are private, like name and license number. So in some situation, we might need to initialize this variable with certain values, and that's where this default constructor will come into picture. And default constructor are supposed to have same name as that of the class, and it is not supposed to have any return type. So that would be like default constructor, and we could like extend this thing further. And so basically, this is a .hp file where we would be having like a declaration, and then we have a .cp file where we would be having a proper definition of each of that method. Okay, so but thing is that over here we don't have over here we don't have um, just over here we don't have like constructor, we don't have default constructor, we don't have copy constructor or anything at all. But when we are like over here, so you would see over there when we are like trying to create instance of that class, and when we get like dog1 and dog2 as objects, so over here we need to set name for like those dogs, and we also need to set license number. So this thing we need to do explicitly and separately, and we could like avoid this extra efforts, and we could get that thing directly when we are creating instance of that class in the form of object by just providing like input or arguments. But for that purpose, you would need constructor, and basically those are the default constructor. So that's the one thing. So the thing that we should keep in mind is like, though we don't have that thing over here, we still could like create certain this thing very easily. If you have like a default constructor mentioned over there, or like if you want to like copy this class or like over here I don't have explanation for that. It means if you want to like overloading operator, I would have something over here. Okay, so whenever like we want to like copy one class into like when we create object out of class like sh1, when we create this object and when we want to use this object, or like when we say like sh2 is equal to sh1, so in that situation what we need to tell you like means we would be having like we need to copy our object, or we need to move that object, or we need to assign a value of that object to another object. So in that situation what we would need to do is we would need like some more functions, and that function are not like defined or declare inside these .hv file. Okay, so compiler means though we don't have like those function defined over here, still we would be able to take means create object out of doc class, and we could like assign it to like another class of like same type. We could like copy it, we could move its resources, we could like assign its resources with the move operator. So and we could also implement destructor. Okay, so all of these things would be implemented by default by the compiler. But when those things are defined by compiler, there will be certain issues. Okay, we cannot be sure about the performance that we will be getting. And to be sure about that thing, what we need to do, we need to make sure we follow either rule of 5 or rule of 0. And what is that rule of 5 or rule of 0? So that says there are like 5 compiler generated functions excluding default constructor. That's like copy constructor, copy assignment operator, move constructor, move assignment operator, and destructor. So rule of 5 says you define all of them at means whenever you are using either of that, or you define none of them. Okay, so that's the rule of 5, means you define all of them for you, if even if you are using one of them. Okay, and you don't define any of them, uh, so that's the rule of 0. So means in our situation we have implemented rule of 0, we haven't defined those constructor explicitly, but we could define those constructor like means those compiler generated functions. So basically, since we haven't defined, so compiler would generate those functions for us whenever it is like compiling our code, and it would add those things to our source code, and using that only we would be able to implement, we would be able to perform certain operation on our object. So compiler generated function are special function generated by the compiler when programmer hasn't added those function explicitly inside our code. Um, so that basically those are like compiler generated function, and those function help us or to deal with classes when you want to create like object out of those classes, when you want to assign or object, or when you want to copy object, or when you want to move object. Okay, so whenever there are operations related to object that are created out of classes, so in that situation we could use these compiler generated functions. So as I mentioned, there are like excluding default constructor, there are like 5 compiler generated function. But first of all, we would also try to understand about the default constructor. So default constructor are nothing but the special functions that are generated by the C++ compiler when programmer um, doesn't code them by himself. So in that situation, compiler would add those functions over there, and those functions would help us with initializing data variable for our data members, okay, that are part of like our private uh, access modifier. So why do we use like default constructor? Default constructor would be used to initialize the data member that would be there inside classes, and that would be like a task of like default constructor. So when we are like, so that's the thing, like means whenever we want to initialize our data members, so in that situation we would use like default constructor. But thing is that like whenever we say like we have defined default constructor could like initialize data members in 2 different ways. Okay, default constructor could initialize data member means default constructor obviously would initialize data member to their default values, but there are like 2 ways in which that thing can be initialized. First is default value initialization, and like this value initialization. So that's about default constructor, means this is how you could like initialize like data members. First one would be like undefined behavior, and second would be like defined behavior. Then if you want, but that thing would initialize your data member to default values, and in most of the cases that would be like 0. But what if you want to add like some constant values to data members? In that situation you would need to use like some more functions, and that's something we call it like data member initialization. For that purpose there are like some techniques. First is like we have member assignment operation, member assignment initialization. We have like uh, member initialization list. So basically member assignment operation, we have member initializer list or in class initialization. So these are the things we need. You can initialize like data members with like certain constant values, and in class initializer preferred or orders. Then once you're like done with the default constructor, what you get is like you would be able to initialize data member to certain value. Next thing is a copy constructor. So whenever you create like object from that class, you would be able to initialize data member to certain value. So that thing is done. But what would happen if you want to, so what would happen if you have created object from that class, and now you want to assign, or when now you want to create like another object of like same type, but you want to assign like properties of like this earlier generated object to that object. So in that situation, you would be using copy assignment operator, sorry, copy constructor. If you want to equate both of them, so in that situation, you would be using like copy assignment operator. Then let's say you want to just don't want to do this do copy of like resources, rather you want to move those resources directly from one object to another object. In that situation, you could use like move constructor and move assignment operator. And move constructor is something prefer more as compared to like copy constructor, but they are like it needs to be defined, or it needs to be considered while writing code. Okay, context is something we should be considering. Next thing is um, like this return value optimization. So in our functions, we have seen uh, we would be uh, we would be like returning object in certain space in memory. Okay, so over there we could also do like certain optimization so that we could like use less memory, and we could like speed up runtime or like speed up execution time. So return value optimization is about that, where we try to avoid temporary object creation, and avoid use of or eliminate the use of copy and move constructor to move data from like temporary object to that memory location where it is supposed to be written. So that is about return value optimization. Since like we have discussed all of these things, now we would go further and we would see like how exactly those things can be implemented. So first of all, I would go inside this compiler generated function, and I would get started with like this default constructor. So I would try to explain what is the default constructor. As I mentioned, default constructor is a special function generated by the compiler if it is not explicitly defined by the programmer inside um, class. Okay, so in that situation, what happens? So default constructor would be uh, default constructor. So my class is like default constructor, and I have means I have added that thing. Okay, so if you see like a default constructor, what it would do, it would try to initialize the data member to some or some default values. So over here, means it's a simple code. So as you mentioned, inside C++ code, we would be having like this preprocessor directive. So we have included our string so that we could be taking data from console and writing to the console. And then we have like this class defined over here. Name of the class is my class, and we have just like one default constructor over there, my class. And we are just, whenever it is called, we would be just giving that right, typing it to like console. And inside main function, we have like my class, means instance of the my class class created, and we have like object over here, obj object over here. So whenever we create like instance of that my class, we should have like that thing printed, and then we are returning 0. So basically this is the thing. So I would just open terminal, and I need to go inside compiler. Since I would be using GCC compiler, I need to mention that thing GCC. On G++, then standard, I would be using C++11. Just make sure like when you're using like smart pointer, like make unique or make sure those things are like supported 14 onward. So you just need to mention that thing over here. So this, so this default constructor dot cpp dot. So when I run this thing, you could see like default constructor called. So basically, whenever we are creating object from that class, it would by means I have just created object out of it. Okay, I haven't called this method my class. Okay, when after creating this like object dot my class. But what you need to understand is like my class method is by default uh, being called, and we got like this output like default constructor called. So that's the default constructor. So whenever you create like object from that class, default constructor is the method that will be called by default, and that's something we use to initialize the data member to certain value. So this default constructor would be able to initialize the data member to default values in two ways. So first thing is it would be so first one is like default initialization, second one is like this value initialization, and I would show you both, and basically it depends on like how exactly you would initialize them, okay, to default values. So let's see this code. So we have like vector and arrow string. Since I would be using like vector over here, so I've included that library. And we have like class by name x, and inside public we have like integer I, we have vector v, and we have pointer p. And inside main, what we are doing is we are creating instance of this class x, and we are naming it to be x1. And when we initialize it to be like x of x1, means so that would be called as a default initialization. In that situation, so over here, whenever I have written this class, I haven't initialized like this integer I to certain value or v to certain value. So basically, when we use like standard vector, so basically it would be like default initialized, but like this pointer and I, they are not initialized to certain values. Okay, but when we use like default initialization like this, means like this class name and then some object name. So in that situation, that would be like default initialize, and you would see like in that situation, if I print like value of I and value of P, so I would definitely get certain behavior, but that behavior would be like undefined or like unintended. So that's the reason we would be able to initialize it to certain values, but that would be like unintended behavior, and that's called as like default initialization of our variable. And then second thing is like call it like value initialization. In value initialization, what we just need to do is like we just need to add like curly braces after like this object name, and that something would initialize these integers and like pointers to default value, and that would be like 0 in most of the cases. And over here you would see like means x of 2 and curly braces, so that would be value initialization. And value initialization is preferred over like this default initialization, because in case of like this x2, we would be able to initialize I to 0 and p to 0, so we would have like more control over that thing. And when I run this thing, you would see, so since I have like compiled most of those things, I would just like run this thing. You would see over here, okay. So whenever I create like means from that class X, I create an object X1, and when I initialize it to be like default way, means using default initialization, the value of x1 dot I and x1 dot p that I get are like this: 822497004. I did not initialize I to this value. Okay, I did not initialize my pointer. Pointer is basically variable which store the address of another variable. So it should be like showing address of some variable, but it shouldn't be like pointing to some like random location. But when I default initialize the default constructor, that would be like means I haven't like defined like default constructor over here. Okay, I have just like defined that thing. So I haven't included default constructor over here. So whenever you haven't, means that's the thing, that's the beauty, that's the reason it's called as a compiler generated function. So default constructor are like compiler generated special function which are used to initialize the data member to default values. And when we initialize this class to be like certain like this default way, default initialized way, we would get like unintended behavior for our data member initialization. And when we initialize them with value initialization, we would be able to initialize our data member to default values, and mostly it would be like zeros or null pointer. And that's the reason for x2 we get like value of I to be 0 and pointer to be like 0. So that's the thing, that's the reason we prefer to initialize them to like value initialized way. Okay, so that's about default constructor. So for default initialization or value initialization, we really don't need to mention or like define default constructor explicitly inside our class body. But when we want to like initialize data member to certain constant values, not to 0, so in that situation we call that as like data member initialization. But in that situation we need to like declare and define constructor, default constructor inside our class body, and that's something you would see over here. So in that situation, you would see like means variables are like declared at the top, and then there is a constructor, and inside that constructor body, we have initialized I to the value of 5 and p to the like null pointer. And when I like run this thing, so I have value initialized this thing. So basically, at first, like whenever I create it, so now it doesn't make sense. Like even if I like initialize to be like default way, still it would be having like same value. Okay, so but when I initialize this thing, like you would see like value of I to be okay. I need to compile it again. Yeah, so now you see like if value of I is 5 and value of pointer p, since it's like pointed to null pointer, it's 0. So that is a data member initialization, means value of I is like even if I like instead of null pointer, if I say like ampersand I, so it would like point to that location. So basically that is the data member initialization, and the method of initialization for data member that you see over here is called like member assignment data member initialization. And thing over there, thing over here is like what you need to do inside like member assignment initialization. You need to write constructor body, and inside constructor body, you need to explicitly initialize each of that variable that we would be using. So member and assignment initialization is mostly used when you have like complex function and a lot of data members in there. So that is the member assignment data member initialization. Fourth thing is the member initializer list. So in that situation, what you do, so you declare like this variables over here, okay, and then while writing constructor body, what you do, you try to initialize those variables with like certain values, okay, in the form of list, so that you see over here. So I of 5, I curly braces 5, that means like I is initialized to value of 5 and p is initialized to the null pointer, and this is a constructor body. So constructor body is mostly empty, but before that only, like after this colon, we have included that thing. Okay, we could also write it this way. Okay, so this is the thing. So this is the default constructor with member initializer list. Okay, so this is the initializer list that means they are like referring to. So I have initialized I to the value of 5 and p to the like null pointer, but we could like initialize to any value. But the thing that we need to mention means keep in mind over here is we have like included those things before constructor body. So if I run it to be like means dot 4, so yeah, again like I need to compile this code. There is nothing wrong about that, just that like means I just want to see the result that I have inside. So you see 5 and 0. So the executable that you see earlier over here, so that was like compiled like I was using another code. So basically this is like in like member initializer list. Using member initializer list, what you do, you would initialize your data member to certain values inside constructor body itself, and then there comes last is the in class initializer. So in class initializer is the one where what you do is like you try to, whenever you are like declaring your data members inside class body itself without having constructor, you initialize them to certain values, like over here public integer I to the 5, standard vector double v, like that's default initialize, and a p to null pointer. Okay, so you just don't declare them, you also include value inside curly braces, and this is called like in class initializer, and you don't need to write like a constructor over here. And so since we could write it, so we could like mention we want to use like default one. Okay, so default one that like compiler would be generating. So this is a way about in-class initializer. So using in-class initializer as well, we would be able to initialize the data member to certain values. And if I like, so you could see like this I is initialized to value of 5 and p is initialized to value of like 0. Okay, so that's like in-class initializer. And out of like this three, so means about for default constructor, first one is like about default initialization, value initialization. So we prefer like we would be having value initialization, so that we would be able to even if we don't use like any constructor over there, we would be able to initialize into default values or zeros. But if you want to initialize into like some different value, you would be using like data member initializer. So that could be like member assignment if it's complex, initializer list. If we would be able, we have like few number of like data members, and last one is in class initializers, where we don't have like constructor body explicitly defined, and we would be using like default. So that's like default constructor to initialize to default values and to like certain values, okay, certain constant values. So that's about like default constructor. Now thing is about copy constructor, okay. So I mentioned whenever we have like also inside like this 5, you could see like means we have this class X, and whenever we are creating like object out of that class X, small x, we are just creating that object, okay. So when we are creating object, when we want to initialize data member, we could use like default constructors in whatever way, default initialize, value initialize, or we could use them to be like member initializer list or like in class initializer, or it could be a member assignment initialization. But what we would do if we want to transfer this object information to another object of like same class. So in that situation, it's like we want to copy resources or like data that is there inside this object X to another object. So in that situation, we would be using copy constructor. So it's like another same code. So we have like this class X, and we have like integer I. Means this is an in-class initialization, and like constructor to be like default one. So basically, when we say like constructor equal to default, that means we want our compiler to include default constructor. Okay, and we could like also disable this constructor by using means delete command over here. Okay, but since we are using copy constructor over here, this is a command for the copy constructor. So copy constructor, so X and then constant ampersand other, and then so we have like this as it we have like this data member initialization, like member initializer list. So I to be initialized like other dot and P to be initialized as other dot P, and this is like copy. So basically what we are doing is like we are transferring resources of like other is like another object, okay. So whatever object that we are feeding in, so whenever like object is feed into the class, or whenever object is written from the function, so sorry, whenever object is feed in as argument to the function, or whenever object is written from the function, so in that situation we would be using copy constructors. In that situation we would be providing copy, I mean this another object as argument, and information of that other dot I transfer to I and other dot P to transfer to P, and that would be like means that would be our like final new object of type X. Okay, so this is like copy constructor. Copy constructor would just copy data member of like current object to a new object of like same class. So that's a copy constructor, and I could show you them over here. Okay, so we have created like, and like this is about copy assignment operator, but yeah, means we would see later on. But first of all, see, we have created like object x1 of type class X, and what we want to do is now we want to transfer, we want to create like another object of same class type X. So return type is of like that same type, which has value same as that of which has like same information as that of stored in like x1. So in that situation we could use like this copy constructor, and if you like print x1 and this x2 information, you would see like both means the information in both of them is like same 22 and null pointer. And second thing is like we have this copy assignment operator. So copy assignment operator is like something which is related to operator overloading. So in that situation, if you observe the code for this copy assignment operator, it's like this is a return type, okay, x ampersand, and this operator equal to, so basically this is like command that we discuss inside operator overloading. So operator is like keyword, and this equal to sign is like operator that we are talking about, that we want to convert into some sort of, we want to overload with like some different functionality. So we have like this thing, and then we are providing this argument x constant ampersand other, and what we are saying, if this means like current pointer to our current object, and other mean pointer to another object. This is equal to like other, means this point, if this pointer is like pointed to other, means since it is supposed to be like pointed to like address of like another location or another pointer. or another object, we use ampersand over here. So if it's the same, then you would return like this information, dereference information back. If it's different, then what we would be doing, like we would be like I is equal to other dot I is equal to other dot p, and like we would return like this information in the home, like dereference information, then we would be returning. So this is like copy assignment operator. So copy assignment operator is similar to operator overloading. Over here, like equal to operator is something overloaded to copy information from one object to another object. So over here, it's not a copy assignment operator. Though we are using equal to sign, it's not a copy assignment operator. It's a copy constructor. We are copying information from like x1 object into x2 object. But in case of like this x1 is equal to x2, so in that situation we are using copy assignment operator, because we are trying to assign all the information that's there inside x2 to x1. So that would be like copy assignment operator. I hope like this thing two things are clear. But in the crux that you should be able to understand over here is like whenever there is an object and we want to create like other object, so we could create like that another object by deep copying information from like earlier object. That could be done either using like this copy constructors, okay, so the simple constructors, or we could use like assignment, copy assignment operator, okay. So we would be assigning same information order. So if I run this code, so you would see like means we had like I value to be 22 over here, initialized to 22, and null pointer that is a 0. So when I print like x1i and x1 dot p, so I get like 22 0. When I copy that information to x2 and when I print information related to x2, object x2, so I get like same information 22 0. But when I change that information x2 dot I to 5 and x2 dot p to null pointer, and when I move x2 to x1, so value of x1 would be is 5 and 0. So that means like copy assignment operator. Means all the information from x2 is now assigned back to x1 when we like change. So I change it over here, okay. So this is how like copy constructor and copy assignment operator works. So just keep one thing in mind: whenever we are providing any object as an argument to the function or returning any um, object from any function or any class, so in that situation you would be using copy constructors, and whenever we have to equate them, so in that situation we would be using copy assignment operator. So that's about copy constructor and copy assignment operator. So next thing that we should look into is copy constructor default. Okay, yeah. So there is one more thing that we need to keep in mind. So over here we are trying to define default constructor explicitly. We are defining copy constructor explicitly. We are defining like copy assignment operator uh, explicitly. But instead of defining them, we could also use compiler generated functions, and we just need to decide whether we want to use them or not. And to use them or not, what we need to do, we just need to include this syntax, okay. So it means left side syntax will be like x parenthesis equal to default. Basically this is a default constructor, so we are saying like it should be default, the one generated by the compiler. X of constant ampersand other equal to default. So basically this is a copy constructor, okay. So to construct information that's there inside other object to new object that will be generated of type from the class of X. So this is like copy constructor. We want it to be like default that generated by the compiler, and this is a copy assignment operator that is the default. Okay. So when we start, means though we haven't defined those objects, still we would be able to get like same result. Okay. So basically these are the compiler generated function, and what we are saying is like we would be using C22000050. So basically these are the default. Okay, means we are using default compiler generated functions, and whenever we don't want to use them, we just need to mention, okay, the constructor is default, but this copy constructor and copy assignment operator we don't want to use them. Whenever we don't want to use them, we could like write delete, means we have disabled them. So in that situation, yes, I would be able to generate like this object x1, since I have like this constructor in a place and I want to use compiler generated one. So I would be able to get that information, okay. So I would be able to get like 22.0, and since I also returning this 22.0, that is there. But when I try to uncomment this, see, I would get like some errors, because what we are doing is we are saying, okay, compiler, don't use like default values, okay. and we have we have disable those copy constructor and copy assignment operator. Output type to be 8. Okay, so you could see like means it's saying we cannot even compile this code, okay, because these functions are like disabled, so we cannot like do copy of operation. It might be able to do, it is a deleted function, so we cannot like do perform this operation. So that's the reason we need, means this is how we could like use certain compiler generated function, or we could define them separately, or we could like go the way we want. So now it's back. But yeah, means you could enable them using default command, you could disable them using delete command. Okay, so this is about copy constructor and copy assignment operator. So until now we have covered like 3 compiler generated function. Out of that, default constructor is like something we need in every situation. We need to define them explicitly if we want to initialize our variables with certain constant values. But this copy constructor and copy assignment operator, we could choose to write them by ourselves, or we could use the compiler generated one. It's always preferred to use compiler generated one. Now there is 3 more actually. First is like so after this thing there is a destructor. So I don't know whether I have included code for destructor over here or not, but destructor would be quite similar to default constructor. It's just that like this tilde sign would be added before that. Okay, so whenever we have like this default constructor, so it would just have like this tilde sign before this, and that would mean this sign before that, and that means like destructor is called. Okay, so whenever I create like this okay, let me try to write this thing. Default. So whenever I create any object, constructor would be called. Whenever object has to be destroyed, this thing would be called. Okay. So default constructor is called. Though we are just creating this object, it's saying like default constructor is called and default destructor is called, because when we create this object, it would be like default constructor is called. Whenever this main function is like terminating, in that situation, this object is supposed to be like destroyed, and in that situation, this default constructor would be called. Okay, so this is called as a destructor. Destructor is like special function generated by the compiler, and its role is to release the resources that are taken. Okay, that are taken means we could be using, so inside this scope. So whatever there inside this curly bracket, that would be considered scope. So we need to release those resources. Okay, so that is the role of like default destruct. Sorry, that is the role of the destructor, and destructor is supposed it is not supposed to be defined by a programmer. Rather, we should be using a compiler generated one, because destructor could have like a lot of parameters in there, because right now we just have like this simple thing, but in our case we might be using like vectors, we might be using pointers. So default constructor would have like proper syntax for that. Destructor would have proper syntax for that, that would be generated by a compiler, so it's better to always use that. Okay, so that's the destructor. Now next thing is move constructor and move assignment operator. Okay, but before going to there is something that I want to talk about, and that's about value expression. Okay, so value expression in C++ are basically statements, or like expression statements, like any line inside C++ code, like this line. So any statement that you see inside C++ code, that can be classified based on whether it can be modified or assigned to another variable. Okay, so just considering that criteria, whether it can be modified or assigned to, there would be like various value categories. Okay, and based on the type of that, like this statement, it would be grouped into like various value categories. Okay, But thing that you need to keep in mind is like value expressions are basically statement. Value expression or the value categories are basically ways to classify any statement. Value categories are the basically ways to classify any statement or expression inside C++ programming language uh, into different classes based on its ability to be modified or like assigned to other variable. So first one is like this uh, G, sorry, L value, like variable. So you could see them. Okay. So this is L value. So value category is also able to assign to modifier. So L values are basically, so whenever we look at like L values, L value is basically L value represent like memory location, okay, memory location, and it would have address. So whatever variable that we see, whatever like this fix operation, or whenever we see pointer, so basically they have like their own distinct address, and we could like change that values. Okay, so means it can be modified or it can be assigned to like another variable. So basically these are like n value expressions, L value expressions. So any variables pointer or like prefix operation that you see, basically these are like L value operations. This L value expressions. Okay, so that's important. Second thing is like PR value expression. So PR value expression is the one which are which does not have like any identity as such, and it represents like temporary value, like any number like this numeral operation, arithmetic operation 2 plus 3, or any like postfix operator. Okay, post fix increment operator. So all these values are like temporary. Means 42 value we cannot modify that value. Okay, it's a fixed number. 2 plus 3, it's like operation. We cannot change that thing, or we cannot assign it to another. Operator overloading is something we do, but like these things are like pure R values. Okay, means these are like temporary values, and they cannot be modified or assigned to, and basically they appear on right hand side of like assignment operator. So L values are basically variables to which they represent memory locations to which we could assign values, and then these PR values are temporary values, we cannot modify them, and they are just represented on right hand side of this equal to sign. Then there is X values. X values are like expression that represent value that can be moved. Okay, and that's something I generally use in like R value references. Use with like R value references to move resources from like one object to another object. But yeah, these are the expression that we generally call it as like expiring value. But there would be like certain time, or they would take like certain time during which means after which they would be expiring. Okay, but it would have like a lifespan until this R value reference is there. Okay, but they would enable to transfer resources from one object to another object, or they would be able to transfer ownership of that memory location to another object itself directly. Okay, so that's the reason they are called as like X value. But for time being, they would be having their like own identity, they would be having like their own memory location, but that would be temporary. Okay, so this is like expiring value or X value. Okay, so over here if you see like my class data and in my class system, so if you create like get temp object out of it, so this thing would be like temporary object, because after some time that object would be like deleted. So any object that you create, so basically that would be like temporary object, because you would be creating it from like my class. So that would be temporary object. And then there is like GL values. So GL values is like generalized L values. So it would include both the things, L values and X values, because they have like own memory locations, and that values can be changed. So like this my classes or something like that. Okay. So what? So if it's like about age L value, a.mm is age R value non-static standard.move. Okay. But X values are basically expiring values. They are like temporary, but they have like some memory location. They are used to move resources from one location to another location, or to transfer ownership. So they have address, but that would be temporary. So that's the reason they are part of like both the things, like means L values as well and R values as well. So generalized L values would have like two things. So first will be like L values and R values, and that represent they would have like some identity in terms of like memory location. They can be changed. Okay, so like a equal to 10. So a is like L value, R reference. So this thing is like integer ampersand R reference. So this is like R value reference. Okay, operator. This is like another type actually. that tends like this R reference is like R value reference, and that is just there to increase the lifespan of this R value a plus 5. Okay, so a plus 5 is not R value actually. A plus 5 is a temporary value because a is like object over here. Okay, means L value. But if it's like 2 plus 3, then that would be like X value, or like some means that would be like PI value. But this R reference is something would be used to increase lifespan of that thing, or would be used to transfer resources. Okay? Means using standard, if it's like L value, then using standard colon colon move, we would be able to like move resources from like this object, this memory location to another memory location, and during that time span it would be like preserve using this like this R value references, or like using standard move command. So when we write it, it should be like this R value, sorry, X value. Okay, or maybe yeah, R value. And then there are R values. R values are like, these are temporary values. First is like PR values, and second is like X values. 2 plus 3 and standard mode. So basically both of them represent like these values would be would would not be able to we would not be able to modify them, but they would be and they would exist for temporary timings. 2 plus 3 is like pure R value, and this standard move A. So it would have like address, but it would be temporary while it is moved from like one resources to another resources. So that's like R value. So we have like 5 categories: L value, then PR values, right hand side of assignment operator, X values to move resources, then generalize L values, and like R values. Okay. So then you might ask like, what is the significance of knowing about this value category? Actually, value category is something would lead us to think about like R value references, because R value references would play like bigger role going forward. And until now we have looked into pointers. Pointers are basically variable that store the address of like another variable, and we would be able to change values that are like stored at that address location. But this pointer would not allow us to move resources explicitly from like one, means it would just give us control over that location, but we would not be able to transfer ownership directly. Okay, if we have to do that thing in that situation, we would need to use like some sort of copy constructor, move constructor, or assignment operators. But this thing like this R value references would help us to move those, because these would have like temporary like temporary object, but that would be able to vanish after some time. Okay, since it's like attached to like R value references. So using these R value references, we would be able to hold any object for a temporary time being, and we would be able to transfer ownership of that memory location to another variable directly. Okay. So if it's like R value reference, then we would be able to transfer that directly using integer ampersand ampersand and that variable name. If it's like L value itself, like means A equal to 5, and if you want to transfer like this ownership of A to something, then we would be using a standard dot move. But thing that we need to keep in mind is like, so that is R value reference. So what basically R value reference is? R value reference is something kind of type that we could use inside C++ programming language, where we use like integer or like something like that, integer, double, bool, or like vectors. So in similar way, we could use like this R value reference operator, like integer ampersand ampersand, and it's like unique. It's not like means it's reference to reference, or it cannot be referenced again. So basically, what it does, it would help us to so it would be connected. This R value reference operator would connect that variable to the temporary object. It could be like simple R value or some timing, or it could be L value through standard.move, and it would be able to hold that for some timing, and using during the timing it would be moved from like one memory location to another memory location, or it would be able to transfer that ownership directly. Okay, so what it helps or what it does is like means whenever we have to move resources from one object to another object, so what we generally do, we use to copy like object from one resource to another resource. But in this situation, what it does, it directly changes ownership itself. Okay, so we say like A is equal to 5 and B equal to 5, A is equal to 5 and B is equal to 10. So what we are saying, the memory location that is named as A holds 5, and then there is a B which holds 10. So if I want to get the ownership of like location that is pointed by a variable A, then I could just directly use standard dot move and this A. So I would be able to transfer that memory location directly to B. Okay, if I consider B to be like some sort of B2B like R value reference operator. So that's the thing that we need to do. So now we would look into this R value references. So as I mentioned, R value references are like temporary object that would help us. So R value references, it's like operator or like type that would help us to like get attached to certain variable for like some period of time, and it would help us to transfer like uh, it would help us to transfer ownership of that location to like another variable. Okay, so in that situation you could see over here. Okay, so I have initialized one L value. So A is like L value expression because it has like memory location, and that memory location holds value 10. So if I want to transfer like this thing from like this if I want to transfer this value from A to B, what I could do, it means whatever value that is holding that memory location without like copying it, what I could do is I could directly transfer ownership of A to B using this R value reference. Okay, so for R value reference, if it's like L value, so I could just type like integer ampersand B equal to standard dot move A, and if I print B, since I haven't defined like B anywhere, okay, I haven't defined B anywhere. So if I like run this code, if I save it and if I run this code, so you could see like 10. So means value of B is like 10. Okay. And how did B get that value? Because R value reference is a like operator which help us to like move ownership of like this L value, um, means that memory location to like this new variable B. Okay. So this is how like we would be able to move this thing directly to B. So that's all about like R value reference. And if I go further, that I could also show you like means why does it matter? Okay. So I also have like one more example. So let's say I want to create I have like this code over here. So this code is about class vector, and I have like pointer data and integer of size. So I am creating vector of like some size, and then I have like this move constructor over here. So basically that would be moving resources from like that. So it means I have like the vector of that size, and I would be probably assigning it to like some another vector. Okay. So generally we would be using like copy constructor in that situation once we create like this create vector, and that's like one way. Okay, but we need to do deep copy from like this 11 to 11 over here. But if you use like no constructor, we don't need to do deep copy. Rather, we could transfer this entire temporary object location. We could call that as like object. Okay, so that's like thing. So what it help is like means when I like save this code and when I compile it, so you could see like move constructor called, destructor called, relocated memory. Let me see. So constructor called allocated 10,000 elements, constructor called allocated 10,000 elements. Okay. So first of all, constructor called, it created 10,000 elements, then copy constructor called, and it copied all those elements to this object one. So it's like copying two times. Okay. So it's using a lot of resources. And over here, it created like this element and then move constructor called. So you transfer ownership of that location directly to object one, and there is no need to call copy constructor. And then once like this normal R value reference operation is done, we could destroy like objects that are created. Okay, destructor is called twice, once for like this one and once for this one. Okay, so and then third one for like the primary one. Okay, because from these we created this, and then these we created this, means once we created these, then we created this, and then this. So we had to like destroy all of that. Okay, one by one. Okay. So destructor is called destructor that move operation, And yeah, so that's all about that. So this is about R value references, but these R value references would help us to write down like move constructor and move assignment operator. And move constructor would have like syntax similar to this. Okay, means output type then vector and percent, but other the data or the data and size and same thing. Okay, so this is but what would change over here is like this ampersand this R value reference operator would be added over here. So that's the beauty about this thing. Okay, so now we will go further and we will look into how exactly this move constructor or like move assignment operator are like defined. Okay, I would just put it down. So move constructor and move assignment operator, and first of all, you would try to understand why do we need move constructor and move assignment operator. So move constructor and move assignment operator are basically compiler generated function if they are not explicitly defined by the programmer, and their role is to uh, move resources from one object to another object. Okay, move constructor would be moving resources from one object to another object of the same class without copying them. And move assignment operator would be again overloaded assign equal to operator that would be able to assign resources of like existing object to new object by directly transferring resources. So move assignment operator or move constructor or move assignment operator would be able to steal resources from one object and would be able to give them to like another object. So that is the best way. I mean, that would be like best way to transfer resources from one object to another object. We don't need to perform deep copy. That's the reason. Whenever we want to like create, whenever we want to like move or like copy resources from one object to another object, it's always preferred to use move constructor or copy constructor, and move assignment operator or copy assignment operator. So that's the thing. Let's see how exactly this syntax goes. Okay. So over here again we have class X. We inside public access modifier we have like I initialized to 22, initialized null pointer, then X default, then this copy constructor default, then copy assignment operator is also default. Okay. Then we have like this move constructor. Move constructor would have syntax like X inside this X ampersand other, and over here like colon signed inside like copy constructor what we have I we initialize that to be like other dot I. We just need like standard dot move over here because this is like L value. Okay, so we just need or like temporary value in this situation X value. So we would need to move resources from other dot I to I, other dot P to P, and this other dot P would be null point. So that would be like constructor body, but that is a move constructor. Okay, move constructor would be able to move resources from object of like same class to object of like new object of like same class uh, without copying them. Okay, so without copying them, you will be able to move them. And then there is a move assignment operator. So syntax would again be same X ampersand operator equal to, and then X ampersand other. So other is like means and same thing like inside same. If this pointer is pointing to this memory location pointed by like that another object, it's same, then return like dereference and return value pointed by that pointer, or perform the standard dot move and all that stuff and return that thing. So that is a move assignment operator syntax that you would see. And over here you would see like operations that are performed. So first of all we have created like object x1 of class X, and we saw value of like I and P, so 22 and 0. When we want to move resources from, so basically in this situation, if we were not using standard.move, that would have been called as like copy constructor, and x2 would be means x2 would be created by copying elements from like x1 to x2, and that would take some time. So instead of that thing, we would be using like this standard.move x1, and that would make sure like we are using since we are using standard.move, the reason we are using standard.move, because over here the argument that we are using is like r value reference, so we need to convert like this L value into r value. So that's the reason we would be using the standard.move. So that's the thing. So that's like copy sorry move constructor, and when we want to like equate them, so in that situation it would like move assignment operator standard dot move. But thing that you need to mention over here, x1 is like L value, and when we want to match them to like this x2, we need to since we want to pass them as argument to like this move constructor, we need to convert them from like L value to R value. And to manage that thing, we would be using the standard.move function. But if you want to maintain the value category of like this x1 to be or like x1 dot I to be like some L value, or to be R value. So in that situation, we could use like standard dot forward, standard dot colon forward, and like integer ampersand, and then this thing. So that something would ensure that like even when we are like moving them forward, their value categories would be like preserved. Okay. So if you just run this thing, so you could see, actually I'm pointing at like memory location because I just wanted to show you like means. So 10, 18, 20, 28, 28 and 10, 10, 18. Okay. So we would be like, I mean, getting new objects, and like then we would be like pointing them to like, though we are like creating new objects, this is the locations where we would be like displaying them. Okay. It is a 10, 18, 20, 28. Okay. So yeah, that's the thing. So this is like move constructor and move assignment operators. Basically, they would help us to transfer resources of like this x1 object to x2 without copying them, rather directly transfer ownership. Okay, using standard dot move. And if you don't want to use like standard dot move, you could also use like standard dot forward, and we would be able to integer ampersand ampersand, and then I we would be, or like x1 we would be able to get same effect, but we would be able to maintain like this. I mean, we would not be changing like value category of this x1 dot I, and same thing goes for like this move assignment operator. So that's all about like this four or like five compiler generator function that we have. There is a last thing that's remaining. So until now we have seen like this compiler generator function. First is the default constructor. Default constructor is a function which are used to initialize the data member to certain values. Means default initialize, value initialize, or we could like initialize some constant value. Then you have copy constructor to whenever we want to pass any object as argument to function or return as an object. In that situation, we would be using copy constructor like x1 equal to x. Copy constructor. Whenever, so in that situation, we need to copy element means information from one object to another object. Same time, copy constructor. Whenever we want to assign, so in this situation we would be using like operator overloading, and we would be assigning that, means we would be copying from one object to another object at the same time. And then there are like value categories, something we discussed like L values, what are the PR values, or then X values, then GL values, and then R values. We discuss about like R value references, so basically kind of like pointer, but the thing is that they would be able to transfer ownership of like one memory location to another variable directly and without copying, and they would save us like a lot of execution time. Okay, whenever we have like huge bunch of like arrays over there. Okay, so it's always preferred, and R value references, and that this something would lead to development of like move constructor and move assignment operator. So basically they would be able to move ownership of like resources of one object to another object. Basically they are used to steal the resources of an object, and we would be generating like new objects using move constructor and move assignment operator, and then destructor, which are used to release the resources. And these are like compiler generated functions. Apart from default constructor, other five that I mentioned. So we need to mention all. We need to define them explicitly, even if we are using one of them. So that's called as a rule of five. Means first is a copy constructor, copy assignment operator, move constructor, move assignment operator, and fifth one is a destructor. So rule of five says even if you want to use any one of them, still we need to define all five of them. Okay, so that's the rule of five. And then there is a rule of zero. That rule of zero says if you don't want to use any of them, then don't define any of that. Okay, that is the rule of zero. So now question would be in your mind which rule to follow. So there is a like order that we need to keep in mind. First is a rule of zero. Okay, if we are not using this, means if there is no need to get into like intricacies. If you don't want to disable or enable or something like that, if you don't want to go like really intricate operation, try to go for rule zero. Try not to define any of this compiler generated function. If you want to have like if you want to ensure some like defined behavior, then try to define all five of them. That is the rule of five and rule of zero. And last one is the return value optimization. So in this situation, if you see over here, we have like class X, and inside that class we have like constructor. We have like this copy constructor, and we have this copy assignment operator. Okay, and we have destructor. So thing is that whenever we are creating like this new object X for this class X, so in that situation, what happens? See, like means what the sequence, what sequence is being followed. Okay, So it would be just so it would be just implementing constructor and destructor. Okay, the first one and last one, it would be creating object and it would be destroying that object. That's the first thing. If I go to, so this is the thing, okay. So I'm just trying to explain return value optimization. Return value optimization is like C++ compiler optimization technique. What it does is it try to eliminate the need to use copy constructor and move constructor to move resources from like one object to another object, or like to return statement, okay, to return statement. So over there we were like returning 0, but basically what we are trying to do is we are trying to minimize the operations that are being performed to move the resources from where they are generated inside function and where they are like returned from that function. So for that purpose, there is like if we could like reduce those operations, that would be considered like return value optimization. In first thing, whenever we create like any object, we would just like call constructor deconstructor. Over here, let's see, we have like same class, but over here, what we have done, we are creating object of type like makex, and inside that object, okay, so we have like this thing added additionally, okay. So means this is like one more method that is being defined. Actually, this is like just let me see. Okay, so this is like additional method. Basically, what it actually it's kind of like function. So this function which return object of type x of that class x, but inside that class this function body, what it does, it create like object of like type x, okay, and that to like value initialize. So sequence is like first of all so this is like function inside main. What we are doing, we are creating object x of class x, so constructor will be called. Second, we are creating like we are calling this function. So first of all, this constructor would be called of type x. Then second thing is what it would be doing is like it would be let me show you what it does. So it calls constructor for first of means for this x, then call constructor for second. Then it calls the since we are like performing this assignment operation, okay. So it performed like this copy assignment operation. So you could see this like operator equal to x constant ampersand. Basically, it shows like the copy assignment operator has been called, and then it calls a destructor for that x, means whenever it this main function goes out of loop, and then it calls destructor for like this first one. Okay. So basically, this is the sequence that follows. But the thing that you if you understand this thing over here, what basically they are doing is they are just making sure the object that x object that is being created, it is of class x, and the object that is written from this make x function is also x, okay. So both of them are like same type, but we have like written this additional line, and because of that we needed to perform like this all these things. So first of all, object was created in like some memory object location with this constructor. Then it was means it was using this copy assignment operator, it was copied to this x, and then this x was destroyed, and then this x was destroyed. So this is like long operation, okay. So what this return value optimization does is, if return value of this function is same is that of like a return value of like this object, so in that situation it would try to it would try to eliminate the temporary object creation like this constructor creation. It would try to avoid use of copy constructor and copy assignment operator, or move constructor or move assignment operator, and directly copy this object into return position, okay. So that's the thing. So if I just like write, and if you see like this third code of RO3 return value optimization 3, over here what I have done is like I have just like means function output is like x that I know, and like x is like of class x. So since whenever like output type of like function is same that of like output type of the object, in that situation return value optimization is like C++ compiler optimization technique, which would try to avoid the temporary object creation to store this make x or like whatever in there, and it would also avoid the need to copy that information to this X location using copy assignment operator, and rather it directly creates object in this memory location of X. Okay, so that is the return value optimization. That's the reason we just have like constructor and this destructor code, because it create constructor and destructor, because this is the only location that we have. Okay, so it construct object in this location itself and destruct itself. That is the return value optimization. Return value optimization only comes into picture if the output of the function matches with that of the output of the object, and means we would be able to avoid like temporary object creation and use of a copy and move constructors or assignment operator, and that would save like a lot of time. So that is the return value optimization. So basically this is all about compiler generated functions. So we look into default constructor to initialize data members. We look into copy constructor to move information from one object to another object. Copy assignment operator, we look into value categories. We look into R value references, that operator which would help us to move ownership from one object to another object. We use it to learn about to write move constructor and move assignment operator. We also learn about rule of 5 and rule of 0. Yes, we to use rule of 5 and use rule of 0. And then we learn about return value optimization, that to like efficiently or like increase the or like reduce the execution time of the code by avoiding the creation of like temporary object and copy constructor and copy assignment operator additionally, and rather directly creating object in a location where they are supposed to be returned. So that's the return value optimization. So that's all about compiler generated functions. So in next session we would learn about resource management. Okay. I hope this thing would be helpful to you. If not, just try to go through all those source codes and like the information that's available on this chapter 2 markdown file, and you would understand most of the things. Okay, so yeah, I would save it. I hope you have learned something useful from that.